Hello everyone, I hope you are all doing good. So continuing with our series, today we'll be solving palindrome linked list question. So question is you are given a head of a singly linked list and you have to return if that is a palindrome or false otherwise. For example, take this example, it's a singly linked list, okay? If you see here, this is matched with this value is matched with this, so that's why it's a palindrome. If we see this linked list, we see this node and this node does not match, okay, so it's a false. So let's say I just create a mirror, okay. So here this node equal distance nodes are matched, but here they are not matched, so that's why it's a false. Single node itself is a mirror, so basically it's a palindrome. Now let's see the idea behind the solution. So let's talk about the idea. So suppose the input is given as a string. So how would you identify whether that is a palindrome or not? It's a simple. What you would have done is you would start one pointer from here. Okay, this pointing to one and another pointing to n. You check if these two value matches. You move the pointer, this pointer in the next and this pointer here. Okay, and then again you check if these two matches. Then you again move and you have a terminal condition. So in the string, it's pretty stable forward, starting pointer and as well as the end pointer, and then you keep on comparing the values. Suppose it's a doubly linked list. Okay, so how would you have done that? Again, you would have iterated, you would have moved till the end, and let's say here's the one pointer here, and the another pointer here. If the both value match, in this case, you have moved to the next, so pointer would have come here. In this case, both value match. In this case, you move to the previous. So now the pointer, these two pointer, so this pointer is pointing to 2 and this pointer is pointing to 2 as well. Again, this matches. So you move it here and again this pointer is moved it here. Okay, so now the pointer is here and here. And you have a terminal condition of null here. So you would have done that easily as well. But in this case, what is currently happening here is there is no way you can move backward. So for example, if there's a pointer here, you can move in the forward direction, but you can there is no way, let's say if you have, even if you would have moved this pointer here and you match these values, this pointer and this pointer, they both matches, so you would have moved this pointer in the next direction, but there is no way you would have moved this pointer in this particular direction. Okay, so to check the palindrome, what you would require is that after comparing this value as well as this value, now we should have compared this value as well as this value, but since you cannot move to this position, this pointer, so there is a no way of doing just like we did for string as well as for doubly linked list. Okay, so that's the complexity here which we are facing. So now let's see how we can solve it. Okay, so one of the approaches, again, you can convert it into string, and basically you take each number, you iterate on number, you create a string just like here, and then you can basically check whether the string is palindrome or not. That's one of the approach. Let's try to do it using this linked list only. So one of the approach here is, as I already talked, that palindrome here means we have to create a mirror, and then equal distance from that mirror, the nodes which are at equal distance should be same. So for example, let's say this is 1, this is 2, this is 2, and this is 1. Okay, so what you would do is you create a mirror here. Okay, do that, and you have to compare this and this and this and this, but you cannot move the uh, pointer in this direction. So one of the approaches, so you can move this pointer in this direction, but you cannot move this from here to here. So what you do is, let's try to reverse this. Let's try to reverse this. Okay, let's after reversal, let's say it becomes 1 and 2. Okay, so you find the half of the linked list and reverse the right half. And now this linked list is something like this. and this linked list is this linked list will be this one. And now you can move the pointers, you can compare the pointers. So you compare this, you compare this. So this is nothing but the AND part. If they are equal, you move the pointer in this direction for this linked list and for this linked list in this direction. Now you see that values are matching. Again, you move ahead. So here it's just like a null, so you won't have to do anything here as well now. So you have to compare till the half part of this linked list. So you will compare till the two part. So if you see both the values or every value while iterating matches, then that means it's a palindrome. So that's one of the approach where you reverse the second half of the linked list and then you do the iteration on the both the linked list. That's the one of the approach. Now let's talk about the another approach here. Okay. So in the previous approach we have reversed the right part and then we did the comparison. So because the problem we were facing is we could have moved in this part for this part of this the first half linked list, but we could not have moved into this particular direction. Okay, so that was the reason we have to reverse it and then we have to traverse it. Now, what if I tell you that without reversal we can actually solve this question? Because what we actually require is whenever we move, whenever let's say we compare these two nodes. Now this node is going to move in this particular node, but this node cannot move. Okay, so we are going to use a recursion here, because in the recursion what usually happens is there is a recursive window for this. Okay, so from this recursion, from this window, it actually the pointer move to this window here to the one. Okay, so one here, two is here, and then this two is here, and this one is here. Okay, so these are the recursive windows. So if I talk about this point, let's say once I compare this and this recursive window moves to this next window. Okay, this next window is representing nothing but this last to previous node here. Okay, and that's what we needed, correct? So once we are done with this, we move to the next recursive window, and now here we always keep the track of the current pointer in this next recursive window. So this is the next recursive window will hold the last node. Okay, and whenever we came across this recursive window, we always have some node which will be pointing to this particular node, which we basically keep track while doing the recursion. Okay, so whenever we came across this, we actually are present in the recursive window of this. So this have value 2, and we always hold the current node value, which is currently 2, and then we compare this value with the recursive window value. If they both matches, then we just return the true in the next recursive value. Okay, and if either of the case, if our value does not match, we will basically return false, and that false is going to propagate into the above recursive value, and finally it reaches the main recursive window from where we have actually started, and finally it will return false as the output. So that's how basically we are going to use recursion here to solve this particular question. Now let's directly jump to the code. So here's the code. Okay, there is a function given and the head is given on this linked list. Now if you see here, we have used one static variable here, temp. So this is nothing but keep tracking of the current node. Okay, so that's why we use this temp. So we have initialized temp as the head here. Okay, and then we pass this palindrome head. Now if you see here, what happens is this is the terminal condition when this particular head becomes null. So there are two things here. If you see, this is your temp. Okay, and there is a head as well. So head is basically moving in the recursive window. If you see here, head is moving in the recursive window, and this temp is is basically updated at some point in the recursive window. Okay. So if you see here, we are moving the head. This is the terminal condition. Head is null, then of course it is a true. Otherwise, we'll get some data, some return value from is palindrome util head next. Whenever we are iterating, we get the response from this particular is palindrome util function. Let's say when we come here, let's say we get the value 1 here. Okay. Now we see the result is true and the temp dot value. So temp is initially nothing but 1 here. You see, it's nothing but 1 here. Okay. If temp dot value is head dot value, currently head is the recursive window is present here. Okay. So the recursive value is 1. So if you see temp value is equal to head dot value, we move the temp here. So now temp goes to 2. Okay, and we return true here. So the value or the control will move to previous recursive window. Okay. Now again we see the temp value is equals to recursive value. We move it to forward and currently move the temp to next. Okay. So that's how we keep track of basically this temp as well as the value in the recursive window. So basically we use temp for this tracking the forward nodes. Okay, and had given that had nothing but represent the recursive window value, and each time we are basically comparing the values, and if it is a true we return true, which is going to propagate it from here and finally would have returned the value here. If it is a false, then false again would come from another recursive value and it would have returned false here, which would have again become false, and finally false would have returned here. Okay, so that's how we use recursion to actually keeping track of the uh, tail nodes or the recursive window values to check the palindrome. So I think that's all from my side. Hope you have followed the solution. Do let me know if you are facing any problem in understanding this solution. I'll happy to help. That's all from my side. Bye. Take care.